Hello. Today I have a short review about what we've learned about evaluating equations and inequalities. The first thing I want to go over is the definition of an equation and inequality. So the definition we had before of an equation was a set of equal expressions. Okay? That's still a good definition of an equation, but I would just note that we have revised it a little bit this week, now that we've been thinking about evaluating it. So you could think of it a little bit more complicated this way. You could think of it as a relationship between expressions that is true if equal. So what that adds is it adds this. So like if I have 2 equals 1, this is still a kind of equation, it's just a false equation. So this definition is a little bit broader than this one, it's a little bit more complicated, and this is kind of what we've added to it this week. Okay? Now we're going to define inequality. So an inequality, you could say it's a set of unequal expressions. Okay? Or you could say it's a relationship between expressions that is true This is very complicated. It's a relationship between expressions that is true if they differ as stated by the inequality sign. So what does that mean? That means that all these different relationships are inequalities, but they can be true or false depending on like how the values of each side relates to the sign. So if this sign says this side has to be greater than this side and it's not, this is smaller than this side, then this is false. And if this one says this is bigger and that's supposed to be smaller and it is, then it's true. And if this says they can be the same or this one has to be smaller, then this is true. And if this says this has to be smaller and they're the same, then it's false. And that's all this is saying. It's saying it's this relationship that depends on the sign. So it's true if the relationship matches what the sign says it should be. Okay? And if you don't want to remember all that, that's totally okay. This is a fine, simplified definition for an inequality. Oh, and don't forget, this is also a kind of inequality. This is a different inequality sign as well. Just says this can't equal that, and they don't, so it's true. now I want to go over a couple examples. Some of these I've already covered, some are new. The first one is just this. All these are going to be evaluating equations and inequalities. So if we're going to evaluate this equation, find out if it's true, when it's true, we would look at it, we notice the variables. So it might be true in certain cases and false in others. And in this case there is a value, actually there are two values that will make this equation true. And one way to figure out what they are is to use some algebraic steps. Like you could divide both sides by x. And you would get this, x equals 1. And 1 is a value that will make this equation true. But there's also another value that will make this equation true that you won't see just by using algebraic steps. You have to sort of think about it for a minute. And you realize that if you plugged in 0, 0 times 0 is also going to be 0. And that'll make this equation true. So the evaluation of this equation is true if x equals 1 or, and this is important, it's not and, it's or, x equals 0. And it's or because either one of these values make it true. It's not like it has to be both 1 and 0 at the same time. That's not possible. Okay? Let's look at this one. X squared is less than 4. So this one's a little bit tricky. I think the simplest way to do it is actually to graph it, which we're going to work on next week. But you can think about it with a little bit of guess and check and intuition and also get the right answer. So what you're thinking about is a number that you're going to multiply by itself that has to be smaller than 4. So we know 2 times itself is 4, so we can try 2. And that's going to become equal to 4, but 4 is not less than 4. Okay, so that's false. But if we plug in anything less than true, 2, it seems like that might be true. Okay, but what if we plug in negative 2? Of course, this is squared, so all negatives are going to become positive. So that's going to become 4 less than 4, which is still false. So it seems like what we actually have is a situation where there's a range of numbers that will make this inequality true, and outside of that range, on either end, more negative or more positive, it's going to be false. And that is how this one works. And the way you represent it is a little bit confusing. You put the x in the middle, okay, and you put a negative 2 over here and a positive 2 over here, and you say that x has to be bigger than negative 2, or you could say negative 2 is smaller than x, and x has to be less than positive 2. So that describes a range of numbers. We'll go over this next week, but on a number line it would look like this. And they're open circles because these numbers are not included. It has to be less than or greater than those numbers. And that's the solution. So it's true if x is bigger than negative 2 and smaller than positive 2. Okay, now that's similar to, but not the same as this situation. Okay, so the difference here is that we have an odd exponent. And we know about odd exponents that they stay negative if they start negative and they stay positive if they start positive. So we're not going to have the range, we're just going to have a single value that's going to be true if it's on one side and false if it's on the other. And we just had to figure out what that value is. So what we're really just looking for is something that when you multiply it by itself 3 times is 27. So we can just try some numbers if you don't know it off the top of your head. We could try 2, 2 times 2 times 2 is going to be 4 times 2 is 8. Okay, it's not 2. Try 3. It's going to be 9 times 3 is 27. So it's 3. Great. So we know the value that's going to make this side equal to this side. But it's not true if x is 3. It's only true if x is less than 3. So we represent that this way. Okay? And that's all there is to this one. Because like I said, anything smaller than this, even if it's negative, even if it's a really big negative, it's going to stay negative. Because it's going to be 3 negatives times themselves, and it's going to stay negative. So this is all there is. Okay. I want to do one that's a little bit of a complex fraction. Okay, so you have to remember how to simplify your exponents in a fraction. So you notice that there are 2 x's on top and 2 x's on the bottom. So you can cancel those. You get this. And there's only one number that when you multiply it by itself 3 times is 1, and that's 1. So, part of the solution to this evaluation is that it's true if y equals 1. But there's another part. Because there was a variable in the exponent, it's not always going to be true if y equals 1. It's only going to be true if y equals 1 and something else. And that something else is that x can't equal 0. Because if x equals 0, this whole thing is going to become undefined. And undefined is not equal to 1. It doesn't have a value. It's just an undefined term. So we have to add that it's true if y equals 1 and it's not or because it's this and it also another thing has to be true, which is that x is not equal to 0. Okay? So this is the solution to this evaluation. All right, that's all I have for the review session. If a lot of this is still seeming pretty confusing, I wouldn't worry about it too much. It is going to become more clear when we go over the graphing, because part of what's involved in the graphing is more of this kind of same algebraic manipulation of inequalities, and I think it'll become more clear as you do that.